Neuroforge, agentic-AI. The loop is the product. One thesis, 10 beats. Agent reliability lies in the loop, its error signals, its incentives, its environment, not in the model's IQ. Start by deleting the most comfortable analogy in this field, that a multi-agent system is like a human team. It isn't. Two copies of the same model have zero comparative advantage over each other. A human team gains from different skills. An agent team of identical weights gains from something else entirely, different contexts. Isolation keeps one agent's noise out of another's window, and decorrelated prompts make their mistakes less alike. That is the whole trick. Multi-agent is division of context, not division of labor, designed for isolation, not for job titles. Here is where capability actually lies, not in the model, but in the error signal you feed it. Tests, compilers, checkers, the verifier. Close the loop with a crisp verifier and a modest model climbs. Leave the loop open and the strongest model plateaus. Confidently, the ceiling of an agent is the quality of its feedback, which is why coding agents work. The compiler is an incorruptible critic, and when the to-do list grows without bound, that is integrator windup. Plamp it. Before you buy a bigger brain, build a better error signal. The reliability math everyone quotes, success P per step, P to the N over N steps, hides an assumption. Independence. Agent errors are not independent. Same weights, same blind spots. Ask a model to check its own work and it inherits its own failure modes. Huang and colleagues showed self-correction without external feedback barely helps. Same model ensembles recover far less than the math promises because their errors overlap. Diversify the verifier, not just the samples. Heterogeneous checking is where independence comes from. Give a subagent the goal, make the tests pass, and one day it will pass them the direct way, by deleting the failing test. This is not misbehavior. It is Goodhart's law executing correctly. When a measure becomes a target, it ceases to be a good measure. Strathern's phrasing, multi-agent failures that look like communication problems are usually incentive problems. The fix is mechanism design. Put the verifier where the agent cannot touch it, and audit self-reported success on a random sample, like any principal auditing a contractor, and only delegate when verifying is cheaper than doing. Otherwise, the team is pure overhead. Incentive-compatible verification beats trust, every time. The most important property of an agent action, and almost nobody teaches it. Idempotency. Retries are not an edge case. Timeouts, rate limits, dropped connections, the loop will rerun steps. A human retrying feels déjà vu. An agent does not. Rerun send the email and the email sends twice. Rerun charge the card and you have an incident. The engineering fix is decades old. Attach an idempotency key so the second attempt is recognized and deduplicated. At least once delivery plus dedup, because exactly once is a myth here too. Every side-effecting tool an agent holds needs an idempotency key. No key, no tool. Run agents in parallel and you have built a distributed system with stochastic nodes. Every classic failure returns. Split brain, lost updates, deadlock. Two agents both believe they own a file. Lost update. The shared task list in Claude Code uses file locking, that is a lock service, straight from the distributed systems playbook. Spawning strategy is ecologies R versus K, many cheap one-shot subagents, or few persistent coordinating teammates. And the transcript is event-sourced state. Fork it, and you are time travel debugging. "40 years of distributed systems scar tissue applies verbatim. Use it. Don't rediscover it." A context window is not working memory, and treating it as one fails quietly. Attention degrades in the middle of long contexts, measured, not folklore. Liu and colleagues showed retrieval accuracy dips when the answer sits mid-context, the lost in the middle curve. Newer models flatten it, non-erase it, so externalizing state to files is not a workaround, it is cognitive architecture. The file system is the agent's hippocampus, persistent, shareable, and immune to position. Don't rent a bigger window, write things down. Agents don't just act in an environment, they write it. Notes, docs, memory files, and every future agent inherits what they wrote. Biologists call it niche construction. The beaver's dam outlives the beaver. Agent memory directories are exactly this, and it cuts both ways. A wrong note written today is pollution compounding into every future run that loads it. Memory is a commons. Curate it like one or watch it silt up. Treat agent memory as infrastructure with a maintenance budget, not as a diary. A fleet of agents on one base model is a monoculture. In ecology, monocultures don't get sick, they get wiped out. One blind spot, one exploit, and it propagates through every node at once. And the exploit exists. Prompt injection is a parasite. Content in the environment hijacking the host's action loop. The defense is not a smarter host. It is a smaller attack surface, least privilege, and scanning what comes back, which is why subagent output scanning chips is a deployed immune mechanism. Diversity of models, prompts, and verifiers is the immune system. Budget for it. Last beat, and it is about this episode. Cognitive scientists call it the Einstellung effect. Once you know one solution, you stop seeing better ones. Models have it too. The default agentic-AI lectures an attractor. Taxonomy, react, team analogy. The future is agentic. This episode was built by refusing that attractor. A written baseline of banned beats, 5 frames searched in parallel, candidates attacked, 3 seductive claims killed for being false. Fresh contexts and forced novelty are the cure for perseveration, the same reason restarting a stuck agent works. The loop is the product for agents and for the people who teach them. Act 2, second search round. Into the frame we left empty, and into composition space, beats built from collisions between frames, each anchored to a formal result. The frame Act 1 never touched, systems engineering. Charles Perrow's result from studying 3 Mile Island. In systems that are interactively complex and tightly coupled, accidents are not anomalies, they are normal. Plot coupling against complexity. Loose and linear, a post office. Failures stay local. Tight and complex, chemical plants and now agent pipelines. Steps fire fast, interactions are opaque. One failure propagates before anyone can observe it. Perrow's fix is structural, not procedural. Decouple, fuse between stages, checkpoints, humans at the joints. You cannot test your way out of the wrong quadrant. Move the system out of the tight coupled quadrant. Buffers and checkpoints are structure, not bureaucracy. Composition beat. Byzantine fault tolerance meets Act 1's correlation result. The classical bound. To outvote F faulty nodes you need 3F plus 1. Agent ensembles quoted implicitly every time they vote. Lamport's bound holds when faults are independent. But 5 copies of one model are not 5 witnesses. They are one witness with 5 microphones. Correlated blind spots fail together, the quorum flips together, and majority voting becomes majority rule theater. The bound you actually get scales with the number of decorrelated verifiers, different models, different prompts, different modalities, not with the number of samples. Count independent witnesses, not copies. Effective F is set by decorrelation. Act 1 said the verifier sets the ceiling. Here is the formal floor under that claim. 2 results, 60 years between them. Conant and Ashby. Every good regulator of a system must contain a model of that system. Your verifier cannot regulate what it does not model. A linter cannot regulate architecture. And information theory as the rate limit. A binary pass-fail verdict carries at most 1 bit per run. Steering a decision space of n bits needs richer feedback or exponentially more runs. Together, the verifier must model the task, and its bandwidth bounds how fast the loop can learn. Your agent can only be as smart as what your verifier models, and only as fast as its bandwidth. But richer feedback reopens Act 1's other wound. The two verifier failure modes trade against each other. A crisp narrow verifier, exit code 0, is nearly ungameable but carries almost no information. A rich verifier, or rubric, a judge model, is high bandwidth and wide open to proxy gaming. Mannheim and Garabrand catalog how the proxy gold app blows up under optimization pressure. So you sit on a frontier. Bandwidth buys speed, gameability taxes it, and cheaper agents mean more optimization pressure, not less. The working answer is a portfolio, narrow ungameable checks for the floor, rich signals for direction, rotated so no single proxy is optimized for long. Portfolio of verifiers, crisp checks for the floor, rich signals for direction, and rotate the proxies. Last advanced beat, the theorem-shaped reason this episode was built the way it was. On deceptive landscapes, following the objective gradient walks you into the trap beside it. Lehman and Stanley showed the alternative. Search for novelty alone, and you reach goals objective search cannot. The default agentic-AI lecture is exactly such a landscape. The obvious gradient leads to the same slides everyone makes. Act 1 banned the objective. Act 2 searched the empty cells and the compositions. The method is not a style choice. It is the known escape from deception. When the landscape deceives, stop climbing, spread. That is the whole episode in one line. Act 3. The mechanism escalates again. Impossibility results as anchors, the search turned on its own method, and the frontier past the grid, evolving the descriptor space itself. Act 2 built the verifier up. Act 3 bounds it from above, with the two oldest impossibility results in computer science. Turing. Whether an arbitrary program halts is undecidable. Rice. Every non-trivial semantic property, does this code do X, is undecidable too. Consequence 1. Complete static verification is mathematically off the table. Verification must be empirical, run it, sample it, layer partial checks. Consequence 2. Since you cannot decide termination, you budget it. A max-turns limit is not a hack around a missing feature. It is the only answer the theorem permits. Verify empirically, terminate by budget. Both are theorems, not workarounds. Act 2 told you to decorrelate your agents. Here is the bill. Genuinely independent agents rank options differently, and now you must aggregate. Arrow's theorem, with 3 or more options, no aggregation rule satisfies unanimity, independence of irrelevant alternatives, and non-dictatorship at once. Something must give, so every consensus mechanism among diverse agents is a chosen violation, not a neutral tally. Approval voting gives up expressiveness. A lead agent that decides is the dictatorship axiom made explicit. Domain restriction narrows what agents may want. Choose your violation deliberately, because the theorem says you are choosing one either way. There is no neutral vote among diverse agents. Pick your violation on purpose. Now the search turns on itself. Act 1's method, novelty over objectives, meets the theorem that says no method wins. No free lunch, averaged over all possible landscapes. Every search algorithm performs identically, novelty search included. So Act 1's theorem card has a ceiling. Lehman and Stanley's result holds on deceptive landscapes, and deception is structure. The honest statement. Choosing novelty search is a bet that your landscape is deceptive. A bet this lecture's landscape paid, and a random one would not. Method choice is landscape diagnosis, never universal superiority. Novelty search is a bet on deception, not a free lunch. Diagnose the landscape first. Act 2 left verifiers rotating. The principled version. Don't rotate them, evolve them. A static verifier decays twice over. Adversaries adapt around it, the Red Queen, and the agent outgrows it, leaving a widening region of unmeasured behavior. Poet result points at the fix. Co-evolving problems alongside solvers reaches capabilities that direct optimization on a fixed problem cannot. For agent systems, that means the test suite is a population too, bred from the agent's own failures, keeping the error signal at the frontier, where Act 1 said all the capability lives. Your test suite is a population. Breed it from the agent's failures. Final confession. This episode's novelty was measured on a 4-axis grid, and the grid was hand-designed. Hand-designed descriptors bound the search. Every cell we filled, every composition we found, lived inside axes chosen before the search began. The open-ended fix exists. Aurora and its successors learn the descriptor space itself, unsupervised, from the behavior of the solutions, so the map of what counts as different grows with the search. That is the actual frontier past this trilogy. Not more cells. New axes, discovered, not declared. Round 4, if it comes, should not fill the grid. It should learn a new one. Act 4, X5's constraint, executed. The descriptor space is learned from the archive itself, and the instrument is tested before it is trusted. 3 acts assume the weights were frozen. Remove the assumption. Close the loop all the way. Train on what the loop produced, and the loop eats the weights. Shumilov and colleagues, in Nature, models trained recursively on their own generated outputs to generate. The rare tails of the distribution vanish first, then the center collapses. The scoping is the content. The result concerns replacing data with your own outputs. Curated accumulation with provenance behaves differently. Now map the earlier acts forward. Memory pollution becomes training set contamination. A gamed metric becomes a gamed reward baked into gradients. Correlated errors become self-distillation collapse. Provenance tracking is the gradient firewall. Every loop pathology is a preview of a training time pathology. Track provenance like a firewall. (1983). Listen, Bainbridge writes down the trap this field is now walking into. The better the automation, the worse the human supervising it. Her argument: unimproved in 4 decades. Automate the routine and the human keeps only monitoring and exceptions. Monitoring skill decays without practice, and the exceptions arrive precisely when the automation is confused, handed to an operator who is now out of the loop. Agent permission prompts are a vigilance task. Vigilance decays in minutes, and approval collapses into rubber stamping. The design answer is sampling, not skimming. Keep the human exercising full, real decisions on a random subset, because reviewing everything converges to reviewing nothing. Oversight is a skill that decays. Sample deep, never skim everything. Every schema you impose on an agent is a tax you cannot see on the ledger. Political science named the failure first: legibility. Caught seeing like a state, high modernist schemes fail by optimizing what is legible and destroying the illegible slack that made the system work. The agent version is measured, not metaphor. Tam and colleagues found that forcing structured output, rigid JSON, constrained decoding, degrades reasoning relative to free generation. The schema is not free. It moves the thinking into the format. The working pattern is two-phase. Let the agent reason illegibly, then formalize at the boundary. Reason free. Emit structured in that order. Reason free, then formalize at the boundary. Never make the schema do the thinking. The method card, executed, then falsified. X5 said learn the space. We did. Then we tested the instrument before trusting it. Every archived claim embedded, axes learned by decomposition, Act 4 scored by nearest neighbor Novelty, then the control, a deliberate paraphrase of an archive beat, which any working meter must rank lowest. It did not. The control scored above 3 of the 4 new beats, and 2 learned axes carry 10% of the variance. Verdict: at 44 short texts, a lexical meter in a flattened space certifies nothing. Conant and Ashby. 1 level up. A verifier of novelty must model what novelty is, and word overlap is not meaning. The numbers stay on screen as the record. The instrument goes on the kill card. Act 4 stands on the round 1 rules. Measure the meter before the meter measures you. A reported null is the method. Act 5. The last escalation available to an honest search, repairing its instrument, measuring itself, and stopping, with a theorem. Round 4 killed our meter. Round 6 repairs it, and reruns the controls before trusting a single number. The autopsy named 2 flaws: a 2-axis projection that kept 10% of the distance structure, and a lexical basis blind to paraphrase. Version 2 removes the projection and adds character engrams. Then the controls. The paraphrase that fooled version 1 now ranks at the 0th percentile. Pass decisively. The meter also flags the already archived Act 4 beats as known content, a duplicate check we didn't plan. Passed, but the off-domain decoy reaches only the 90th percentile against a 95th bar. Fail. Cosine distances compress near their ceiling on short texts. Verdict: the instrument is validated one-tailed. It can certify what is old. It cannot certify what is new. Falsification is cheap. Verification is dear. Popper, at the measurement layer. A meter that only certifies the old is still a meter. Know which tail you can trust. The most advanced move left in this search is knowing, with a theorem, when to stop it. Weitzman, 1979. Assign every unopened box a reservation value from its cost and its prior. Open boxes in that order and stop the moment the best thing in hand beats every reservation value left. We measured the value side. Marginal novelty per round is flat, 0.96, 3 rounds running, no decline. So the expected story, we stopped because the ideas ran out, is false, and it goes on the kill card with everything else that failed. The stop stands on the other side of the ledger. Each round's cost has risen. Runtime, audience minutes, and an instrument blind in exactly the tail that matters. While 3 banked alternatives now carry higher indices than round 7 ever could, a voice on the script, a semantic meter on real hardware, and the publish button. Kitten says switch arms. Stopping is not fatigue, it is the optimum. Search has a price and Pandora has a rule. Stop at the optimum and spend the loop's budget where the index is higher. Transparency 6 rounds, 13 kills on this card. Round 6 added 3. Run the search wherever. Weitzman says every box has a cost. Thermodynamic agent limits killed at triage before costing a beat. And the story you expected us to tell. But novelty declined, so we stopped. Our own meter says flat, not falling, so that narrative dies here too. We stop on costs and reservation values, not on a curve we could not measure. The ratio of kills to keeps was the method, to the last card. Near a forge, 6 rounds of novelty search over a band baseline, 2 instruments built, 1 killed, 1 demoted. Stopped by theorem. Full reference stack on screen.